Now this is a Unity tips and tricks course, but of course Unity is designed to work nicely with other applications where we have to model assets for importing into Unity. So that's why I am here in Maya and not Unity, to try and show you some tricks that I use when exporting my assets to make sure that I get the best performance from them when they are imported into Unity. Now you can see the scene in front of you is a kind of a board game scenario that I am using for one of my game projects. Now these meshes here are not included in the course files, but that's okay because what I'm going to show you are some general principles that apply to your own meshes generally. Now I'm giving these instructions in Maya, but the basic principles apply whether you are using 3ds Max, Blender, or whichever software you prefer to use. So the first thing that I like to do is to get a kind of feel for how many polygons and vertices are in the scene. So to do that, in Maya, I click on Display, Heads Up Display, and I can choose Poly Count. And this will give me some statistics and information about the faces, edges, vertices, tris, and UVs in the scene. So for example, I can select this house object here, and it tells me that there are 2006 triangles in the current selection. I can press F on the keyboard and zoom in on that selection to get an idea and feel for how this is. So this can be a useful tool to try and diagnose a number of triangles and vertices in your different meshes. Generally, the lower the number, the better the performance will be in Unity. Now these numbers do not tally exactly with what will be in Unity because Unity calculates vertices and edges slightly differently from Maya and other modeling applications. So these numbers will not necessarily tally with the triangle counts that you will get when imported into Unity. Having said that, the lower you can make them in Maya will mean that they will be lower in Unity too. Okay, so what else can we see? Well, generally the principle here is to use as few triangles and polygons as possible, but still in keeping with your design. Now the next thing to consider is that before we go ahead and export any one of these different meshes, one of the first things that we should do in Maya is delete the history and the transformations. And I can do that by selecting a mesh, choosing Edit, Delete All by Type, and then History, and I can also choose Modify and Freeze Transformations. When I have selected both of these options, I am then free to go ahead and export the mesh using File, Export. And you can export this as a Maya ASCII, a Maya binary, or an FBX file. Generally, I work with Maya ASCII files which have the extension of MA. They import into Unity absolutely fine, generally speaking. So the next thing I want to have a look at is mapping and UVs. In particular, if I just press space to open up the UV editor here, you can see that we've got a texture sheet for our scene. Now, one of the general principles is to try to make as many of the different models share the same texture as possible. So what we are building here effectively is an atlas texture. So I select, for example, this model, and you can see, bam, we've got this different locations highlighted where it uses this texture. And practically all of these objects in this scene in some way reference this texture. They use the same texture. And the more objects you can have that share the same texture, the better performance will be when the object is imported into Unity. So in short, try to share textures wherever possible. Now, this applies not just to keeping most objects mapped to the same texture itself, but we can also overlap UVs to save texture space. Consider, for example, this windmill. If I just zoom in here on this wall for the windmill that you can see here, we have 1, 2, and 3 elements. Now we have 1, 2, and 3 sides here, but we have another 3 sides on the other. And what's happening here are these 3 different pieces of the wall are overlapping. They are sharing these same UVs. So this mapping here is effectively mirrored, we are recycling these UVs, and that's a pretty good thing to do. It's one thing to bear in mind, however, with overlapping UVs, is that we also want to try to minimize the number of UV seams possible in our model. That refers to the place where we have to cut apart the UVs into independent shells. We want to have as few edges and seams as possible, because when we import our model into Unity, it will double up all the vertices on the seam. So if we have a vertex there and a vertex there, then Unity will double up on those vertices. So by increasing the number of UV seams in our model, we indirectly increase the vertex count of our models in Unity, and that could affect performance if we have enough UV seams. So try to minimize the UV seams possible. Okay, so with that said, there are some other small little tidbits that we can pick up on here. For example, you'll see that when I select this model, it also selects this model and this model. And again, if I move over here and I select this model, it selects this one and this one as well. And that is because these models are combined. I could, for example, have separated out these different models and exported them separately and then imported them into Unity, each and every one as a separate model. But that is not generally the optimal way to work in Unity. Rather, try and identify all the models that are close together in the game. So this building appears near to this one and this one. These appear close together. And because of that, we can export them together. And notice that their polygon count is about 3,960 tries. Now, so long as we keep 4,000 or below, generally that represents an ideal number for a single batch. So we can export these together. They're below 4,000 triangles. This makes a good single model together. So try to combine together as many meshes as you can which appear close to one another in the level, provided that their triangle count is 4,000 or below. You can find that you can optimize your game in that way. So that's some basic tricks on how you can optimize models for export from Maya. What I'm going to do now is jump over to Unity and consider a few extra things that we can do there to optimize our models. Okay, so quickly jumping back into Unity, we can explore at least two optimization techniques that we can perform with meshes once they are imported into Unity. What I have here is a cube and a sphere, and these have been generated using the standard Unity primitives, but the same applies to meshes and any other game objects as well. One rule that I would say is that if your object does not use collisions, collision detection, or the physics system at all, then you can visit the object here and remove or disable all box and other collider components. So if you never need to bump into this object, if this never needs to receive collisions or any sort of thing like that, then you can remove or disable the component like so. Also, if the object does not receive or cast shadows or has no effect with shadows at all, then I recommend disabling the shadow casting properties. That can certainly hold back performance if you are casting shadows there. And something else is that the static property up here. Any objects that do not move, do not scale or morph or change or animate in any way, things such as floors, walls, ceilings, buildings, tables, chairs, if none of these things move, then select all of them and group them together by clicking the static checkbox. If you mark them as static, you are signifying to Unity that these things cannot be moved. And if they are sharing the same texture or material, then Unity can perform various batching and optimization operations on them that can radically improve the performance of your game. So I recommend enabling the static checkbox wherever possible. Always aim to enable static if you can. So that's just a brief overview of some of the techniques that we can employ in Unity to improve the performance of our game on imported assets.